So you can represent LTI system by nth order constant coefficient differential equation. So firstly, we'll find the characteristic equation, right? If a question is given. So after finding the characteristic equation, we'll find the roots of the characteristic equation. If the roots are real and distinct, so the natural response will be k into e power RT. If they're complex conjugate, you have of the form a plus or minus j omega, you'll have e power at into k1 cos omega t plus k2 sin omega t. If they are real and repeated, if the roots are repeated, then there is one more method of solving that. It is r to the power of p plus 1, and you'll have e power rt into k naught plus k1 of t, like that. Okay, if the two roots are repeated, so you'll get minus 1 and minus 1. So it will be e to the power of minus t into k naught plus k1 into t, that form. Okay, we'll solve that problem also if possible today. And yeah, forced response is called as zero state response. Okay, so that here we consider input and we take the particular response. Okay, we find the particular response. After finding the particular response, we'll add that with the natural response. Okay, when you are finding the forced response, that time you have to take zero initial conditions. Okay, and this is the structure of particular response. Yeah, I was discussing this problem in the last class. So you have been given a differential equation. Try to get the characteristic equation, okay, and find the roots of the characteristic equation. So the roots are real and distinct. So it will be of the form k1 into e power minus at plus k2 into e power minus that roots you have to substitute here. Okay, s1 into t plus k2 into e power s2 into t. So first, by using the initial conditions given in the question, you have to find the k1 and k2. Okay, that will be your natural response. Okay, after finding natural response, you will be finding the forced response. So for forced response, you need particular response and natural response. So find the particular response. Okay, try finding particular response. So for that particular response, you will try to write the particular response in the form of differential equation, right? So you'll find out the constant and you'll get the particular response. So forced response is natural response plus particular response. So when you're finding again the forced response, don't substitute k1 and k2 values whatever you have got in natural response. This time you have to take initial conditions as 0 and you have to find k1 and k2. After finding k1 and k2, try to get the forced response and substitute the natural response which you had got previously along with the forced response. That will be a total response. Okay, so take down one more problem today. Evaluate the total response of the LTI system. Evaluate the total response of the LTI system described by the differential equation. Described by the differential equation given below. So you have y double dash of t plus 4 times y dash of t plus 3 times y of t, which is equal to 36 t into u of t. Okay, this is the given differential equation, and the initial conditions are y dash of 0 is equal to 1 and y of 0 is equal to 0. So what is the first step? What is the first step? Can anyone tell what is the first step? So we'll find the characteristic equation. So depending upon this differential equation, so you have s square plus 4s plus 3 is equal to 0. Now find the roots of the characteristic equation. What do you get? What are the roots of the characteristic equation?
3 and -3 -1.
Yeah, so 3 ones are 3. If you add that, you'll get 4. So s square plus 3s plus 1s plus 3 is equal to 0. So s into s plus 3 plus 1 into s plus 3 is equal to 0. So you'll have s plus 1 and s plus 3 is equal to 0, where your roots are s is equal to -1 and s is equal to -3. Okay, so what is your natural response? The roots are real and distinct. So natural response will be yn of t, which is equal to k1 into e power minus t plus k2 into e power minus 3t. Okay, substitute the value of s here. So now we have to find the constants k1 and k2 by considering the initial conditions. So try to find the k1 and k2. What will you get? In this yn of t, substitute t is equal to 0, you will get yn of 0, which is equal to, y of 0 is given to be 0, right? So y of 0 will be equal to 0, which is equal to k1 plus k2. This is your equation 1. Then next you find the differentiation of this, first derivative of this. So yn dash of t would be equal to -1 into k1 into e power minus t plus -3 into k2 into e power minus 3t. Okay, this is your first differentiation of yn of t. So y dash of 0 is equal to 1. Substitute t is equal to 0, you will get yn dash of 0 will be equal to 1, which is equal to, and put t is equal to 0 in that. So you'll get minus k1 minus 3 k2 is equal to 1. Got it? This is equation 2. Try solving those two equations to get k1 and k2. Did you follow this step, everyone? Is it clear?
Yes, ma'am.
Clear, everyone? So natural response is of the form, this form, right? So now if you substitute, make use of these initial conditions and find yn of 0 and yn dash of 0. You'll get two equations. Now you find k1, k2. What is k1, k2? Yes, guys, what is k1 and k2? Are you solving or not?
I'm 1 by 2.
What is k1? What is k2?
1 by 2 minus 1 by 2.
So k1 0.5 and k2 is minus 0.5. Did everyone get this?
Yes, ma'am.
Okay, now you substitute that in yn of t. Yn of t is 0.5 into e power minus t minus 0.5 into e power minus 3t. Got it? This is your natural response. Okay. Next, you have to find the particular response. So what is the input given? 36t into u of t is the input. So what is your particular response structure? So particular response we are finding now to find a forced response. Forced response is the summation of natural response plus particular response, yp of t. We'll find yp of t first, then we'll add it with natural response. So particular response, we take input x of t is equal to 36t into u of t. So what is the structure of particular response? You have T here in the input. So if you have T, what is the structure of particular response? Just check the table and tell me what you will get. What do you get if it is T?
C naught plus
C naught
C1.
plus C1 T, ma'am.
If it is T, C naught plus C1 into T, correct? If your input is of the form T, C naught plus C1 into T. Got it? So you will get C1 as well as C2 here. That is C naught and C1. Okay. So your particular response is of this type T. If input is T, the particular response structure will be C naught plus C1 into T. Sorry. C naught plus C1 into T. You have to find C naught as well as C1. Okay. So how do you find C naught and C1? So Yp of T will be of the form C naught plus C1 into T. So how do you find this C naught and C1 constants? How do you find C naught, C1? We'll find C naught and C1 by substituting particular solution in the given differential equation. Okay. So you have Yp double dash of T plus 4 Yp dash of T plus 3 Yp of T is equal to 36T into U of T amplitude 1. Okay, so we have taken 1 here. Got it, everyone? You're substituting the particular solution in the given differential equation. This is a differential equation given, right? S square plus 4s plus 3. Got it? Now you find what is Yp dash of T and Yp double dash of T. So what is Yp dash of T? It's the first differential with respect to this. So what do you get? C naught is a constant, so that will be 0. C1 into T, what will you get if you differentiate?
C1, ma'am.
C1. Yp double dash of T, if you differentiate this again, what will you get? C1 constant.
0, ma'am.
0. So substitute this in this equation. First take down this, then you put this in this equation. It will be easy. So 0 plus 4 C1 plus 3 C naught plus C1 into T is equal to 36T. So what do you have? 4 C1 plus 3 C naught plus 3 C1 into T is equal to 36T. Now how will you find C naught and C1? How do you find C naught and C1? You have 4 C1, 3 C naught plus 3 C1 into T is equal to 36T. You have to compare the coefficients of power of T. Here you have T term, here also you have T term. Compare the coefficient of powers of T, right? So what do you have? What do you have? 3 C1 is equal to 36. So what is C1? We are trying to compare the coefficients of the power of T. Got it, everyone? So you have t power 1 in these two. So we are equating these two to find C1. Got it? Is it clear?
Yes, ma'am.
The coefficients which are powers of t. Here you have t term, here also you have t term. So 3C1 is equal to 36, C1 will be equal to 12. Similarly, if you find C0, so 3C0 plus 4C1 is equal to 0, correct? It is having the power T0, right? T power 0. You don't have any t term for this. So we have equated that to 0. Did everyone follow? Compare the coefficients of power of t. Got it? Are you following or not?
Can I explain once again?
Yes?
Can I explain once again, ma'am?
We are comparing the coefficients which are having the power of t. Okay? So you have t term here, so I have equated those two. So in this step, what we are doing is we are comparing the coefficients of the powers of t. You have t term here, so we have equated that. So 4C1 plus 3C0 doesn't have any t term, that is t to the power of 0. So that is 0 only. Got it? These term we are equating it together, and that is 3C1 is equal to 36. And here we are equating 4C1 plus 3C0 to 0. Because we don't have any t term, right, in these two. This term has a t term, even this term has a t term, so we are equating this. Here you don't have t term, so we have equated that to 0. Got it? Clear?
Yes, ma'am.
So now you put 3C0 plus 4 into C1, we have already found out 12. Okay, which is equal to 0. So 3C0 is equal to minus 48. What is C0? It will be minus 16. This is how we find C1 and C0. Is it clear? Equate the coefficients to the powers of t. Whichever coefficients are there, with the power of t, you equate it. Here you have t power 0, that will be equal to 0. Here you have 3C1 into t, which is equal to 36t, so equate these two. Got it? Clear, everyone? So yp of t will be of what form? It will be minus 16 plus 12 into t. Minus 16 plus 12t. Got it, everyone? Particular response? Clear? Is it clear?
Yes, ma'am.
Now you find the forced response. Forced response is the summation of natural response plus particular response. So your natural response was of the form k1 into e power minus t plus k2 into e power minus 3t. Okay, you should not take the values of k there, whatever you have solved it for natural response. Just take k1 and k2. This k1 and k2 you are finding by assuming zero initial conditions. Okay, in forced response. Minus 16 plus 12t. So this is the given equation for yf of t. Okay, forced response you represent as yf of t, that is equal to k1 into e power minus t plus k2 into e power minus 3t minus 12 plus 12 minus 16 plus 12t. Now we have to find the constants k1 and k2. So how will you find the constants k1 and k2? By assuming zero initial conditions, we have to find that. Okay. So yf of 0 would be, if you put t is equal to 0 in this whole equation, what do you get? You get k1 plus k2 minus 16, which is equal to 0. Take this as equation 3. Now you find the differentiation of
Ma'am?
this. Yes?
Ma'am, we should not substitute the value of k, ma'am.
No. That is for natural response alone. That you have done, right? When you are finding the forced response, again you have to take k1 and k2. And you have to find the k1 and k2 by using zero initial conditions.
Okay, ma'am.
Got it? So if you substitute t is equal to 0 in this equation, you will get k1 plus, so this will be e power 0, that will be 1. So 12 into 0 will be 0. So this term will go. So you have k1 plus k2 minus 16 is equal to 0. This is first equation. So now you take yf dash of t, first differential. So what do you get? Minus 1 into k1 into e power minus t plus of minus 3 into k2 into e power minus 3t plus 12. If you take differentiation of this first differential. Now you substitute t is equal to 0 to get y f dash of 0. You'll get one more equation to solve k1 and k2. So what equation you have? So you have minus k1 minus 3k2 plus 12 is equal to 0. This is your equation 4. Now try solving equation 3 and 4 and try to get the values of k1 and k2. What is k1 and k2? You can solve it in the calci, right?
Ma'am, is it 18 and minus 2?
Yeah, it's 18 and minus 2. So now you write yf of t, which is equal to 18 into e power minus t, correct? Minus 2 into e power minus 3t minus 16 plus 12t. Okay, this is your forced response. Clear, everyone? It is natural response plus particular response. Got it? Clear, everyone? So now you can find the total response y of t, which is equal to natural response plus forced response. What is natural response? I had put a bracket box right for that. What is natural response? Previously, which you had founded, right? K1, K2. That is your natural response. That is 0.5 into e power minus t minus 0.5 into e power minus 3t. That is natural response. And forced responses, which you have founded now. Got it? So that would be 0.5 into e power minus t minus 0.5 into e power minus 3t plus 18 into e power minus t minus 2 into e power minus 3t minus 16 plus 12t. This is your total response. Got it, everyone? Now if you want, you can solve this. These two. So you'll get 18.5 into e power minus t minus 2.5 into e power minus 3t minus 16 plus 12t. So that would be your y of t for t greater than or equal to 0. Or you can write this equation multiplied with u of t. 18.5 into e power minus t minus 2.5 into e power minus 3t minus 16 plus 12t into u of t. Got it, everyone? Clear? Is this problem clear, everyone?
Yes,
You want me to explain once again? See here, when you have your differential equation, try to find the roots of the characteristic equation. That is the first step. If the roots are real and distinct, you will have k1 into e power minus, k1 into e power st plus k2 into e power st. Okay, s1 and s2. k1 into e power minus, k1 into e power s1t plus k2 into e power s2t. Okay, what is our s1 and s2? It's minus 1 and minus 3. Substitute that. k1 into e power minus t plus k2 into e power minus 3t. That is your natural response. Okay. In this equation, you have to find k1 and k2. How will you find k1 and k2? By making use of the initial conditions given in the question. These are the initial conditions given. Y of 0 is equal to 0, y dash of 0 is equal to 1. So make use of that initial conditions. So for yn of 0, you're substituting in this equation t is equal to 0. Directly you will get. To find yn dash of 0, you find the derivative of this and then substitute t is equal to 0. Okay, you'll get two equations, find out k1 and k2, then you'll get the natural response. Next, we are trying to find the forced response. Forced response is natural response plus particular response, right? So try to find the particular response using the input. So input is of the form t, so particular response will be c0 plus c1 into t. Okay, so now write that in the form of differential equation. Okay, yp double dash of t plus y4 into 4y p dash of t plus 3yp of t is equal to 36t. U of t is 1. You can ignore 1. You can take it 1. So now we have yp of t. Find the first differential of this, second differential of this. So what you get? You get 0 for second differential. First differential you will get c1 and yp of t c0 plus c1t. Substitute the values here. Yp dash of 0 is 0. Yp double dash of t is 0. Yp dash of t is c1. So 0 plus 4c1 plus 3 into c0 plus c1t is equal to 36t. Now we have to find c1 and c2 in particular equation. Okay, particular response. So try to equate the coefficients to the powers of t. So if you have t term in these two terms, so equate that. So here you don't have t term, so equate that to 0. You'll get c0 and c1. Now write the particular solution, particular response. Yp of t is c0 plus c1 into t. Our c0 is 16, c1 is 12 into t. Okay, c0 into t will be 12 into t. Now find a forced response. Forced response is natural response plus particular response, right? Now you write k1 into e power minus t plus k2 into e power minus 3t plus particular response. Don't substitute the values of this natural response which you have got previously. You have to find now again by considering 0 initial conditions. Okay, so that will be equal to 0. Okay, whatever it is, it will be equal to 0 in this step. So now find differential of this. Substitute first t is equal to 0, you'll get this equation 3. Then find differential and substitute t is equal to 0, you'll get equation 4. Now find k1 and k2 and try to get the forced response equation. Now add natural response which we had done first and the forced response which we have done now. So you'll get the total response. Is it clear? Clear everyone?
Yes, ma'am.
I'll give you one problem, try to solve that. Evaluate the total response of the system described by the differential equation y double dash of t plus 4 y dash of t plus 3 y of t which is equal to 3 x double dash of t. And they have given you x of t is equal to 4 into e power minus 2t into u of t. The initial conditions are y of 0 is 0 and y dash of 0 is also equal to 0. So try solving this. So here directly they didn't give you x of t, they are giving you 3x double dash of t. So x of t is 4 into e power minus 2t into u of t with initial conditions y of 0 is equal to 0, y dash of 0 is also equal to 0. What is the roots of the characteristic equation? You have s square plus 4s plus 3 which is equal to 0. The roots are s is equal to minus 1 and s is equal to minus 3.
Ma'am, x of t is e power minus 2t, ma'am.
Yeah, 4 into e power minus 2t into u of t. What is natural response? Yn of t. It is equal to k1 into e power minus t plus k2 into e power minus 3t. So what you get? K1 and k2. Both initial conditions are 0. Observe this. So what is your k1, k2? If both the initial conditions are 0, your k1 and k2 will also be equal to 0. Okay? So yn of t will be equal to 0. Got it? Because both the initial conditions are 0, you will get k1 and k2 0 only. Keep that in mind. So natural response is equal to 0. Try to find the particular response. So particular response, x of t we have to consider while taking particular response. It is 4 into e power minus 2t into u of t. So what is the structure of particular response? What is the structure? It's 4 into e power minus 2t into 1. What is the structure of your particular response? Check the table and tell me. It is of the form, if input is of the form e power at, what is the structure of particular response? It is
C
c
into
into e power at. Okay. So now your yp of t will be equal to c into e power at form. Okay, e power minus 2t. So yp of t will be equal to c into e power minus 2t. Okay, now find c. How will you find c? By putting the particular solution in the differential equation, right? So we have yp double dash of t plus 4 yp dash of t plus 3 yp of t is equal to x of t, which is equal to 4 e power minus 2. Find this c and tell me. So here you have 4 into e power minus 2t. Find the differential and put it in the equations.
Ma'am,
Yes.
in above, ma'am, e power at to c into e power at you written, no, ma'am.
Yeah.
After that, you are not considering 4, ma'am. Why, ma'am?
No. Input is of this form, e power at. We have in the input, we have e power at. Correct? So particular structure will be, particular response structure will be c into e power at. Some other constant this is. Don't put 4 here. That constant you have to find. Got it?
Yes, ma'am.
Input you consider only e power at. If you have e power at input, your structure of particular response will be some constant into e power at. That constant you have to find. Got it?
Yes, ma'am.
So yp of t is given. What is yp dash of t?
minus 2 c e power 2 e power minus 2t.
C into e power minus 2t is yp of t. Yes, tell me once again. Yp dash of t.
Minus 2 c e power minus 2t.
Yeah. Now yp double dash of t will be
4 c e power minus 2t.
yeah. Substitute this in this equation. In this equation, you substitute that and try to find c. So you have 4c into e power minus 2t plus 4 into minus 2c into e power minus 2t plus 3c into e power minus 2t is equal to 4 into e power minus 2t. So e power minus 2t is common. So you have 4c minus 8c plus 3c, which is equal to 4. So what is c? You get minus c is equal to 4 or c is equal to minus 4. Got it? Is it clear? So what is yp of t? It is c into e power minus 2t. So c is minus 4 into e power minus 2t. Got it, everyone? Clear? Clear or not? Are you guys solving or simply you're...
Ma'am, can you scroll it a bit upwards?
Yeah.
Still more, ma'am.
So we have found out particular response. Now we find out forced response. Done? Rakshita, done?
Yes, ma'am.
So yp of t is done. Now you find forced response, yf of t. It is natural response plus particular response. So you have k1 into e power minus t plus k2 into e power minus 3t minus 4 into e power minus 2t. Now you find k1 and k2 assuming zero initial conditions. How will you find k1 and k2? This is yf of t is equal to 0. So if you substitute t is equal to 0, you get k1 plus k2 minus 4 is equal to 0. So next, if you find differential of that yf dash of t, get minus 1 into k1 into e power minus t plus, minus 3. Minus 3 into k2 into e power minus 3t minus plus, right? You'll get plus 8 into e power 1 minute. Yeah, minus 8 into e power minus 2t. So if you substitute t is equal to 0, so yf dash of 0 would be equal to minus k1 minus 3k2 plus 8 is equal to 0. This is your equation 3 and equation 4. Try to find k1, k2.
Ma'am, it's 2 and 2.
2 and 2. K1 is also 2, K2 is also 2. So what is your forced response? Substitute that K1, K2 in this equation. Okay. So yf of t is equal to 2 into e power minus t plus 2 into e power minus 3t minus 4 into e power minus 2t. Got it, everyone? For t greater than or equal to 0, or you can write this equation and multiply with u of t. Clear? And And they have given you one clause also there. So till here everyone clear?
Yes, ma'am.
But in the question they didn't give differential equation equal to x of t. They have given you it is equal to 3 times x double dash of t. RHS is 3 times x double dash of t. So using superposition theorem, your yf of t will be 3 times y double dash of yf double dash of t. Okay. So this is yf of t. So RHS they have given you as 3 times x double dash of t. So yf of t will be equal to 3 times yf double dash of t. So find the double differentiation of this and multiply it with 3. So yf dash of t will be equal to minus 2 into e power minus t minus 6 into e power minus 3t plus 8 into e power minus 2t, yf dash of t, right? And yf double dash of t will be equal to 2 into e power minus t plus 18 into e power minus 3t minus 16 into e power minus 2t. So 3 times yf double dash of t will be equal to 3 into this 2 into e power minus t plus 18 into e power minus 3t minus 16 into e power minus 2t. So that will be equal to 6 e power minus t plus how much is that? 18 into 3? 54. 54 e power minus 3t minus 16 3 is a 48 into e power minus 2t. Got it? Clear?
Now, what is that, ma'am? Yf of t equals 3yf double dash of.
See, they have given in the question, they have equated, what is your RHS in the question? In this question, what is RHS? It is 3x double dash of t, correct?
Yes, ma'am.
So yf of t is the forced response. RHS is 3 times 3x double dash of t. Using superposition theorem, we can write total response is 3 times yf double dash of t. Got it?
Yes, ma'am.
Ma'am, in previous problem for yn of t, we got some value, no, ma'am. Here we took 0 y, ma'am.
Which one? Here you have got both initial conditions 0, right?
In previous problem also it was 0 only, ma'am.
One was 0, one was 1. If you observe, here both initial conditions are 0, so your k1 and k2 both will be equal to 0 here. So natural response is 0.
Okay, ma'am.
Got it? In previous problems you see, this will be 0, this will be 1 or vice versa. Any one will be 1.
Is 1.
So if you have both initial conditions 0, directly you can write k1 is equal to 0, k2 is equal to 0 in natural response. Understood everyone? This problem? For t greater than or equal to 0, or you multiply it with u of t, this equation. Done?
Yes, ma'am.
So you take down one problem. I will solve it in next class. You try this. You'll get roots, equal roots for this question. So evaluate the total response of LTI system described by the differential equation, which is equal to y double dash of t plus 4 y dash of t plus 4 y of t is equal to 2 into e power minus 2t into u of t. Initial conditions are y of 0 is equal to 0 and y dash of 0 is equal to 1. So try solving this. Okay, and in this question there is sub questions also. Find the total response if x of t is equal to 2 times e power minus 2t into u of t, but initial conditions are changed. Y of 0 is equal to 0 and y dash of 0 is equal to 2. You have one more sub question. Find the total response if y of 0 is equal to 0 and y dash of 0 is equal to 1, but x of t is equal to 4 times e power minus 2t into u of t. You try solving the first part, second, these two I will show you. You try this one. If you have repeated roots, what you have to take, you try that. I'll solve it in next class, this question. Got it? You have any doubts? Understood how to find natural response, forced response?
Yes,
Is
ma'am.
it clear? These are
Yes,
different
ma'am.
types of problems. Okay. But you have to remember the table. For particular response and natural response. If you remember the table, then you can do it properly. You can write your name and yourself in the chat box. Thank you, students.